We're going to finish up our work on partial fraction decomposition looking at repeated linear factors in our denominators, and that process looks a little bit different again than the last two types of partial fraction decomposition that we've worked with. So we're going to consider what happens when one of the factors in the denominator is linear, but it's a repeated factor. So let's look at this. Here, if we look at our denominator and we factor it out, we have a repeated linear factor here. This is x times x plus 3 times x plus 3. And so we have to set that up a little bit differently than we would any of the other two that we have done. And what's different about it, we don't have to put any x's in the numerator because they are linear factors, but we do have to consider that in this common denominator, there could have been the linear term x plus 3 that doesn't necessarily show up because we wouldn't have written x times x plus 3 times x plus 3 squared. That x plus 3 is included in this term, if that makes sense. So it feels like we are, that this is kind of a non-necessary term, but it is necessary because if I was to ask you to find the common denominator to these three fractions, you would tell me that the common denominator was right here. And that would, that would mean that we would have to include that as a possibility for one of the terms when we added them together to get this fraction. Again, if it wasn't the case, we don't have to worry about it because we're just going to find that b equals 0. But if it is the case, then we need to make sure that it's included there because our numerator would look very different if this term was not included. So the first thing we'll do is multiply both sides like we've always done by the least common denominator, and we know that there are things that will cancel. It'll cancel on the left-hand side and we'll just be left with the numerator. And on the right-hand side, we're going to multiply each fraction by the common denominator. There are common terms top and bottom that will cancel in each one of these terms, so we'll clean that up. And we'll just wind up with no fractions anymore. We do need to distribute here and distribute through and get all of our a's and b's and c's and so forth with their corresponding x terms or constant terms. And then we gather like terms. A plus b is going to be the coefficient of x squared. 6a plus 3b plus c is going to be the coefficient of x, and then our constant is just going to come from 9a. We know what to set a plus b equal to because it has to equal 13. We get that over here from the coefficient on the left-hand side. We know 6a plus 3b plus c has to equal 48, and we know that 9a has to equal 72. So we can take all these steps and then set up our systems of equations based on what we get from the right and left hand side. It's very easy to solve for a. We know that a equals 8. We can substitute a equals 8 into this equation. We find that b therefore would equal 5, and then we can substitute the values of 8 and 5 into this equation, and we find that c equals -15. So this partial fraction decomposition, or this fraction, came from the addition of these three fractions. And it turns out that that second fraction was important in finding the numerator, the correct numerator for that fraction. Let's talk about one more possibility, and that's that the polynomial in the denominator has a smaller degree than the one in the numerator. For instance, we can see here the degree in the numerator, the highest degree is 3, and the highest degree in the denominator is 2. So since the degree in the numerator is larger than the degree in the denominator, we have what's called an improper fraction. And partial fraction decomposition is not going to work on this because the degree is higher in the numerator. So we need to take steps to make this into a proper fraction, and that comes from polynomial long division. And we did that last fall, if you'll remember. So we take the denominator. We divide it into the numerator following that long division process. We look at the lead term here, ask ourselves, what do I need to multiply this by to make it look like this? And that's 2x. So then we multiply each term by 2x. We get 2x cubed minus 4x squared minus 15x. Then we subtract them. 2x squared minus 2x cubed is 0. Negative 4x squared minus a negative 4x squared is 0. And 15x minus a negative 16 leaves us with a positive x. And then 5 minus 0 is 5. Whatever our remainder is, we put it over our divisor. And so now we have a polynomial term and we have a rational term, but it is proper. The highest degree in the numerator is smaller than the highest degree in the denominator. So if we want to find the original terms that were added together to give us this fraction, one of those terms was 2x. Now we need to decompose this fraction to find out what the other terms were. So we're just going to concentrate on the fraction because we know 2x is still going to be one of the terms. So we do the same process that we did. We have two linear terms. We know how to do partial fraction decomposition with linear factors. So we'll just go through that process, multiply both sides by the denominator. On the right-hand side, we're going to cancel what is common from that common denominator, distribute through. Again, we don't have to distribute. At this point right here, I could say when x is negative 2, I get negative 2 plus 5, so that's 3. This term goes to 0, and it's negative 6b. So negative 6b would have to equal 3. b is going to equal negative 1/2, and so on. But we'll go ahead and do it like they have it on the slide. So here, we know that a plus b is going to have to equal 1, and 2a minus 4b is going to have to equal positive 5. That's where these two come from. And probably we can just use substitution as opposed to, well, they use elimination, so we'll use elimination as well. Here, we're going to multiply this by negative 2, and then we can add them together, and our a's will be eliminated, and again we do find that b is negative 1/2. Then we can substitute into either one of those equations and find the value of a. So a is 3/2. So when we substitute that back in, a is 3 over 2, and minus b is negative 1/2. So here is the decomposed fraction of this improper fraction that we started with. So that's it. That's it for partial fraction decomposition. Come to class next time and we will practice some more of this type of problem.